What is up mga ka-farmates? It has been ages since I last posted. Some of you knew me for my gaming content, but you know that life has changed and so did I. But now I am back, not with gameplay contents, but with tutorials. I am Ian Manuel Carvajal, currently a second-year pharmacy student from the University of San Agustin. And today we are kicking off first with Molarity. And then for the second part will be about Molality, and for the third will be about Normality, as this will be a three-part series with regards to the expressions of concentrations in the course of physical pharmacy. And just a quick note that if ever I make a mistake or miss something, I truly apologize. I'm still a student, just sharing what I have learned so far. So let's learn and grow together. Now, without further ado, let's get right into it. So, first things first, what exactly is molarity? Now, molarity has a symbol capital M, and it is the number of moles of solute dissolved in 1 liter of solution. So the formula will be capital M is equals to, with a numerator of number of moles of solute must be in grams over liters of solution. And of course, as the name suggests, liters, of course, the unit will be in liters. Now, let's get right into the practice problems. A pharmacist dissolves 12.5 grams of sodium bicarbonate in 200 milliliters of water to prepare an antacid solution. Find the molarity. Now, the first thing we need to do is to find given, which are the 12.5 grams of sodium bicarbonate and the 200 milliliters of water, which is the volume. Now, let's write it down. Given the mass of the sodium bicarbonate, which is equal to 12.5 grams. Next is the volume, which is equal to 200 milliliters. And molarity, which is still unknown. Now, the next thing we need to do is to convert. Now, the question is there a need to convert? Yes, and it is the volume. Because the volume, as given, is in milliliters, not in liters. So we should convert it. So 200 milliliters times 1 liter over 1000 milliliters, so that it will cancel out the milliliter unit. So it will be equal to 0.2 liters. Now, after converting out the givens, as it will be used in the formula, is to find the molecular weight of our solute, which is the sodium bicarbonate. So the molecular weight of our sodium bicarbonate is to be solved like this: sodium, hydrogen, and carbon, and also oxygen. So each element will be like solved each, so that we can add them up and it will be served as their molecular weight. So sodium is 23. Oh, no. It's supposed to start with kato, ikat, ato, ikat, ato, ikat, luat. Now, molecular weight of our sodium bicarbonate. So let's write it down, that each of those elements behind the compound. No. So how many sodiums are in the compound? 1. Hydrogen is also 1. Carbon is also 1. And oxygen is 3. Multiply by their masses, which is sodium has 23 grams. Hydrogen is 1. Carbon is 12. And oxygen is 16. These are all rounded off for, easy memorization. Now let's all add them up. 23 times 1 is 23, 1 times 1 is 1, 1 times 12 is 12, 3 times 16 is, sorry, I'm not good with math, 48. Let's add them up. 23 plus 1 plus 12, 12 plus 1 plus 48, it's 84 grams per mole. Always remember that our molecular weight is in grams per mole unit. Now, after that is to find the moles. And the moles formula is moles is equal to mass of our solute over the molar mass or our molecular mass, which is 12.5 grams for the mass of our solute, and then the solute's molecular weight, 84 grams per mole. So the grams will be cancelled out, so leaving the mole unit. So the answer will be 12.5 over 84 84 is equal to 0.1488 mole. In my case, in solving for the moles, aside from the final answer, I think it's better if the decimal points will be higher than 2. But only in the final answer will, let's just say, will stay to the 2 decimal points answer. Sorry for my bad English. Now, let's proceed. After finding out the mole of our compound, let's start in finding the molarity. So the molarity's formula is equal to moles of the solute, right, over liters of solution. Now, is our given already will be able to complete the formula of molarity? Yes, moles is here and the liters is here. So let's all write it down. So 0.1488 mole over liters, which be 0.2 liters. Now let's solve for the molarity. 0.1488 over 0.2 liters. So the answer for this question will be 0.74 moles per liter. And always remember that our molarity unit is moles per liter. Now this is the answer for our first question, which is 0.74 moles per liter. And as I have said, that in my case, for the other answers will be in greater than 2 decimal points, but in the final answer will be staying in 2 decimal points. Now on to our second question. To compound an ophthalmic solution, you need 50 milliliters of 0.15 molar boric acid. How many grams of boric acid are needed? Now in this case, it is not the molarity which we'll be solving for, but we will be solving for the mass of our solute. Now, the first step is find the given. Our given, which is the 50 ml, milliliters, which is the volume, and then the 0.15 molars of boric acid. This is molars. Now, let's write it down for our given. Volume is equal to 50 ml, and then our molar is equal to 0.15 moles per liter. Now, I forgot the mass of our boric acid, which is still unknown. Now, the next step is to convert, right? So we have to convert what needs to be converted, which is the volume, because it is still in milliliters. Now, 50 milliliters times 1 liter over 1000 milliliters. That cancels out the milliliter unit. It will be 0.05 liters. Next is to solve for the molecular weight of our boric acid. Molecular weight of our boric acid. But if ever the molar mass or the molecular weight of the solutes are already given, this is not a need anymore for you to solve. Now continue. So H, hydrogen, boron, and oxygen. How many hydrogens are in boric acid? 3. Boron, 1, and oxygen is 3. So hydrogen's mass is 1, boron's is 11, and then oxygen's is 16. 3 times 1 is 3, 1 times 11 is 11, 3 times 16 is 48, right? Let me check. Yes, 48. So 3 plus 11 is 14, 14 plus 48 is 62. So 62 grams per mole. Now after that is, we need to find the moles. Now, after which, we can try to solve for our moles. Now, our formula to get our moles can be moles is equal to mass over molecular weight. But we can't solve for the moles because we don't yet have the mass. What we can do for now is to find the moles in another way. Yes, we can try to use our molarity formula. Now, molarity is equal to moles per liter. We can derive it into moles is equals to molarity times liters. So our moles is equal to molarity, which is 0.15 moles per liter, times our volume, which is 0.05 liters. Now let's try solving it. 0.15 times 0.05 is equals to 0.0075 mole, canceling out both liters. So this will be the moles, 0.0075 moles. Now that we have the moles, we can solve for the mass using the formula of mole is equals to mass over molecular weight. All we need to do is to derive it, which is mass is equals to moles times our molecular weight. So it will be equal to mass is equal to moles, which is 0.0075 times molecular weight, which is 62 grams per mole, is equal to, oh, I haven't written it down, 0.0075 moles times 62 grams per mole, cancelling both mole. So the answer is 0.465 grams, or 0.47 grams. You have 3 grams of acetaminophen and want to prepare a 0.1 molar solution. What volume of solution in milliliters can be prepared? Now, our givens are only the mass of the solute and then the molar, but the volume is missing. Now let's find our givens, which are the 3 grams of acetaminophen, 0.1 or 0.1 molar solution, and that's it. Let's try to write it down. Given our mass of our acetaminophen. Acetaminophen's chemical formula is C8H9NO2, which is equal to 3 grams, and then the volume, which is equal to my mistake. I'm supposed to write down the molar, or the molarity, is equal to 0.1 molars, and our volume is unknown. Now, do we need to convert anything, or is there something we need to convert? Not anymore, because the numerator is already in grams and volume is still unknown. So let's try to solve for the molecular weight of our acetaminophen, or the solute. Molecular weight of C8H9NO2. Now, carbon, hydrogen, nitrogen, oxygen. How many carbons do we see in the compound? It's 8. Hydrogen is 9, nitrogen is only 1, and oxygen is 2. Times 12, 1, 14, 16. So 8 times 12 is how much? It's 96. Hydrogen is 9. 14 is 14, of course. And 2 times 16 is 32. Let me check. 256. What? No, it's 16. Sorry, my bad. It's supposed to be 32 grams. So 96 plus 9 plus 14 plus 32 is equal to 151 grams per mole. Now, after we found out our molecular weight is to find for the moles. We can find for the moles because we have our mass as a given, and we have found the or solved for the molecular weight. So our moles formula, just MOL is fine. Or please write down in the comment section if it's supposed to be mole or with an E, or I don't know. I'll stick with the MOL. So mole is equal to 3 grams over 151 grams per mole, which is equal to 0.0197 mole. I forgot to cancel. Now that we solved for the mole, is to now solve for its volume. But what formula can we derive to solve for the volume? That's right, we will be using the molarity formula. Molarity's formula is moles per liters of solution, which will be derived into liters of solution is equal to mole over molars. Now, let's fill out the following. Mole is 0.0197 mole. And for our molar, which is given, is 0.1 moles per liter. Cancel mole. The answer will be 0.0197 over 0.1, which is equal to 0.7 liters. Is that the final answer? Yes or no? No, it's not yet the final answer because it has been stated that the volume must be in milliliters. So let's try to convert it. So 0.197 liters times 1 liter, 1000 ml. Cancel. So the final answer would be 197 milliliters. That's the volume. Now on to the other question. A lab assistant prepares 1.5 molar calcium gluconate solution weighing 39.6 grams in a 100 milliliter solution. What is the density of the solution? Now first we need to find the given, which is 1.5 molar and then the 39.6 grams in the 100 milliliter solution. Now let's write it down. And then the mass is equal to 39.6 grams, and then the volume is equals to 100 milliliters, and then the density, which is unknown. Now, is there a need to convert anything? No, but the question is, do we really need the given of the molarity? In this case, maybe not, because the formula for density, which is D is equals to mass over volume, has already, or the values are already in the given, which are that mass that is 39.6 grams and the volume, which is 100 milliliters. And take note that the 39.6 grams is for the whole solution and the 100 milliliters as well, as it will be used in the formula of density. But we can't yet use the formula if it is stated that this 39.6 grams, for example, is only for the solute and not for the whole solution. And if the volume is only for the solvent but not the whole solution. So in order for us to use the formula is to first find the mass for the whole solution and the volume for the whole solution before using this formula. Now, let's fill out. D is equals to, what is the mass? 39.6 grams over 100 milliliters. Now let's try to solve it. Which is 0.396 grams per milliliters, which is the unit for density. Now, this 1.5 molar is just a distraction. As long as it has been given or stated that stated the mass and the volume for the whole solution, then you can just directly use the density formula. Now on to the last question for molarity, but with sub-questions, of course, or subparts. Now, a formulation requires dissolving 7.66 grams of sodium chloride in water to make 250 milliliters of solution. First, we need to answer the letter A, which is what is the molarity of the solution? Let's write down the given and find it, of course. The given are 7.66 grams of sodium chloride and then 250 milliliters of solution. Now write it down. Mass is equals to 7.66 grams and then volume is equals to 250 milliliters and the molarity is still unknown. Now convert volume, right? Oops. Cancel. Equal to 0.25 liters. Now after finding or converting it, is to find the molecular weight of our sodium chloride. They're just one for the compound. One each for the compound, I mean, like one sodium and one chlorine. So sodium is 23 and chlorine is 35.45, which are equal to 58.45 grams per mole. Now let's try to solve for our mole. Mole is equal to what? Mass over molecular weight. Our mass is 7.66 grams. And then our molecular weight is 58.45 grams per mole. Cancel. So 7.66 over 58.45 is equals to 0.1311 mole. After solving for the mole is to solve for the molarity. Now molarity is equals to moles over liters. So 0.1311 mole over 0.25 liters. The answer will be 0.1311 over 0.25 is equals to 0.52 moles per liter. This will be the molarity for the first question. Now that we have solved for the first part, it's now for the second part, which is what is the mass of sodium chloride in 500 milliliters of the same solution. So our given are now 7.66 grams of sodium chloride, 500 milliliters. Oh, sorry. We don't be needing this anymore because it is being asked, or we are being asked to solve for the mass, for the new mass, for the new volume in the solved molarity, of course. Now let's write down the given, which are the molarity is already solved, which is 0.52 moles per liter. And then let's the volume, which is 500 milliliters. And then the to be solved mass, which is still unknown. Now the molecular weight also of sodium chloride is already solved in the first part. Now the next thing we need to do is to solve for the mole. But how can we solve for the mole if we don't have the mass? That's right, we derive. With what formula? Is it the mole formula or the molarity formula? We can't use the mole formula because, first things first, we don't have the mass. And also, we don't have the mole, so no. So let's use the molarity formula. Molarity is equal to mole over liter. So mole is only missing, and we can derive it for us to find the mole. So mole will be equal now to molar times liters. So let's solve it. 0.52 moles per liter as solved in the first part times the new... Oh no, I forgot again about conversion. Don't follow me, guys, because I always forget about it. Anyways, convert 500 milliliters into liters. Cancel. Oh my god. 0.5 liters. So now that we have solved for converted the volume, is to use it to find our mole. Cancel the liters. Now solve for it. 0.52 times 0.5 is equals to 0.26 mole. And now that we have solved for the mole, is to now use this for the formula of mole. So mass over molecular weight, and derive it as mass is equals to mole times molecular weight. So our mass will be equal to 0.26 mole times the 58.45 grams per mole. So 0.26 times 58.45 is 15.197 grams, or is equals to 15.20 grams. So this will be the mass for sodium chloride in a 500 milliliter solution. And on to the last part of the question is, what is the density if the final mass of solution is 265 grams? So our given is the solution's mass, which is 265 grams. Now, we have solved for the volume, or it has been stated here, 500 ml, or sorry, wait lang. Wait. Volume is equals to 500 ml. And then the final mass is equals to 265 grams. Now, can we solve it directly in the formula of density? Yes, because the volume is for the whole solution and the mass is also for the whole solution. So density is equals to 265 grams over 500 ml. 265 over 500 is 0.53 grams per milliliters. Now that's all for molarity, guys, and I hope you have learned. And also I apologize for my very bad English and for my very bad pronunciation of terms and all. So I hope this video will help you go on and study about molarity. And for the next video will be about molality, so stay tuned because it will be posted right after this. So, or it will be posted, the link will be posted in the comment section. So guys, thank you very much and have a good day.